Okay, so we've got here two points A and B, okay, and they're given by these position vectors, A and B. So remember, these are just coordinates, okay. Little a tells you how you to get to A from the origin, okay. So go along that vector there, vector A to get to A, and then similarly then to B, you go along little b, and you get to B. So they're position vectors. Now if I want A to B, okay, if I want a vector going from A to B, okay, along there, well of course, I don't know what it is, but what I can do is go from A to O, okay, and then O to B. Now A to O is the sort of reverse of A, isn't it? So that's why I've written minus A there, and then O to B is plus B. So we can rewrite them, we can write then AB as B take away A, right? So B is this up here, 7I minus J plus 5K, and then we want to take away then A, which is that, so put in the bracket to appreciate we are taking it away. So we get 7I minus I will become plus 8I, because two minuses make a plus, minus J minus 3J is minus 4J, and then 5K minus 7K, minus and minus become plus, so that'll be 5K plus 7K, which is plus 12K. Alright, so that's the vector A, B. Then it says, part B, the point C lies on the line AB and is such that AC to CB is in that ratio 3 to 1. Find the position vector of C. Now, it's really good to have a sketch in these situations, okay? Because we can actually position where C is here. It's on the line AB, isn't it? Somewhere here in this ratio. So A to C and C to B are in this ratio 3 to 1. So I'm going to position C so that we've got, it's actually going to be closer to B, isn't it, if you think about it? Because in that ratio, it's divided 3 to 1. There's 4 parts in total, isn't it? So if I divide this AB up into 4 parts, okay, roughly here on my sketch, okay, that would be 4 parts, wouldn't it? Yeah, 1 part, 2 parts, 3 parts, 4 parts. But AC to CB is 3 to 1. So I need to put C here if you think about it. Okay, that's where C needs to go, because A to C is 3 parts, and C to B is 1 part. Okay, just like I've got in my ratio up here. Okay, so 3 to 1. Now I want the position vector of C. In other words, I want OC. Okay, that's what we mean by position vector. How do we get from O to C? Okay, we don't know what it is, but we know O to C can be thought of as O to A, yeah, plus A to C. So to get from O to C, you could think, well, let's go to A, O to A, and then when I'm at A, I can just go directly A to C, okay, which is great. And then, if we think about A to C is going the same direction as A to B, isn't it? Yes, going along the same line, but it's a fraction of it, yeah? So we can think of this as a fraction of A to B. Okay, that's what A to C is. Okay, it's a fraction of A to B. And the good thing is I can actually work out what that fraction is. So if you think about it, the ratio is 3 to 1. So to get from A to C, it's like 3 out of 4, isn't it? Because I want to go most of the way, isn't it? Most of the way of A to B. But I need to cover 3 parts. Okay, to get from A to C, I need to cover 3 parts of A to B out of a total of 4. So it's be 3/4 of AB. So it's a case then, I'm just plugging in the terms. Okay, so OA, remember, is little a, so it's that. So minus I plus 3J minus 7K, plus then 3/4 of AB, which is this here. Okay, so 8I minus 4J plus 12K, right? So I can work that out, minus I plus 3J minus 7K, 3/4 of 8I is going to be 6I. Use your calculator to check that. 3/4 of minus 4J can be minus 3J, and 3/4 of this here will be 9K. Okay, and then it's a case of putting them together. So minus I plus 6I is 5I. 3J minus 3J is 0J, isn't it? So I don't need to write that down. And then minus 7K plus 9K is plus 2K. Alright, and I've got my position vector OC, happens to be 5i plus 2k. Alright, and we're done. So then the next part then, it says the vector equation of the line L is given by this here. Okay, and then it says find the vector equation of the line parallel to L which passes through A. So this is quite straightforward actually, okay, because if you think about it, it says it's parallel to line L, okay, and if it's parallel to line L, it's going to have this same direction. Remember, this represents, as we discussed in the last videos, this represents the direction, okay, so that's going to be in my next to my lambda, although in this case now I'll use a different, I'll use mu, okay, but it goes through A, so my line, my new line, okay, will be R equals, because it goes through A, right, we'll have this minus I plus 3j minus 7k plus then mu. Okay, so I've gone through A, so I have that point there, and put this in to show the direction. Okay, and we're done. You know, we can group the i's, j's and k's together as we normally do, but that's essentially it.